Okay, so there were a couple of questions with homework, so I just want to look at those for a sec. 15 in 4.5 in our first homework with use substitution, we're looking for a way to get rid of this 5x because we have a function within a function, and given that 1 minus x squared is inside, that must be the composite that I'm looking for is trying to figure out stuff. So I am going to use 1 minus x squared as my u sub. Du dx for that is negative 2x. And so when I cross multiply, I get du equals negative 2x times dx. So I'm cross multiplying. Now I divide by negative 2x so that I can substitute this in for dx because I have a dx here. So I'm going to rewrite my integral now. I'm going to say the integral of 5x times the cube root, or how about just u to the 1/3 power. And instead of dx, I'm going to write the equivalency du over negative 2x. All of these are multiplied, so there you go, multiplication. This x and this x will cancel. 5 over negative 2, well, that's just a scalar multiple. So I'm going to pull that out, and now I have u to the 1/3 du. This is in the same variable, so I can integrate now. And I have two negatives, sorry. Okay, so negative 5/2, the integral of u is going to be u to the 4/3 over 4/3 plus c, or negative 5/2 times 3/4 u to the 4/3 plus c, and that's equal to negative 15 over 8 u, which is 1 minus x squared to the 4/3 plus c. So 15 may not have been as intuitive as the other ones because 5x doesn't look anything like what we chose to u sub. So what I really needed to find is that when I took a derivative, I would cancel out the x, because I know I can't integrate if I have x and u in the integral. So just having the x was enough for me to know that I would cancel that out, and then this became the multiplication that I needed, so that if I check this with multiplication, things would cancel back down to give me the 5. So 15. The other question I had was for number 23. So we have the integral of 1 plus 1 over t all cubed times 1 over t squared dt. So this is all in t. I can still do u substitution. That doesn't matter. If you prefer to change this all to x, you can do that. Just at some point you'd have to say t equals x and then rewrite it. So I'm going to choose the inside function. Inside the cube, it's always the inside function. U equals 1 plus 1 over t. When I take this derivative, so u du dt is going to be, notice how I'm taking the derivative of u, but it's with respect to t. The derivative of 1 is 0. The derivative of, I'm going to consider this to be t to the negative 1. That'll be negative 1 t to the negative 2. Or negative 1 over t squared. So this is enough to tell me that I have the t squared here in the bottom. So we could actually sort of mark this out and put a negative in the front, and then it would all work out. But it's nice to see the substitution work. It's magic, and things actually cancel. So I'm going to cross multiply. I'm going to ignore this in the middle and cross multiply dt with negative 1. Negative 1 dt equals t squared du. I'm still trying to solve for dt, so if I multiply this side by negative, then that will be my substitution. So I'll rewrite it. The integral of 1 plus 1 over t is u cubed. 1 over t squared. 1 over t squared. Instead of dt, I'm going to write negative t squared du, so times negative t squared du, and then the t squared is in the top and in the bottom, and they cancel. One more time, I'm going to rewrite it just so I don't get lost in all the crossing out of stuff. So I have negative in the outside, u cubed du. It's now all in terms of u, so we can integrate. And that'll be negative u to the fourth over 4 plus c, which when we substitute in is going to be negative 1 plus 1 over t, that was my u, to the fourth over 4 plus c for 23. The book, when they write their answer, they pull the 1/4 out in the front, but obviously that's the same answer. So if you're trying to match that exactly and see it, you can take the 1/4 out to the front, and either of these is perfectly fine. Okay, so in our lesson today, I have some more problems that are new. I didn't know what other ones to go over for review, so I didn't include any other actual problems. But you're welcome to email me ones that you're still confused about or that you have tried again since we've done more work with U substitution, and I can do those specifically for you. Okay? Thanks, guys.